All right, greetings YouTube. This is Beautiful Mind. This question comes in from Trig on inverse trig functions on finding the exact value in radians of y, or stating that y is undefined. So we're given y equals inverse cotan of all right. Shoot. So y equals inverse cotan of negative square root of 3. All right. So let's look at it. All right. So if we have y equals inverse cotan of a negative square root of 3. So what does this mean? In class we said that this means what? Cotan of y equals negative square root of 3, right? So then what is cotan? Cotan is a reciprocal of tan, right? So this means, well, this is 1 over the tan of y equal to a negative square root of 3, right? So then you can cross multiply and divide, and ultimately you'll get that the tan of y equals 1 over negative square root of 3, all right? So notice that the tan of some angle is negative, and we have 1 over square root of 3. So tan of what angle is 1 over the square root of 3? Let's see. So it sounds like it's 60 degrees. Let's look at 60 degrees. If we look at tan is 60 degrees, right? That's going to be sine over cosine. 1, 2, 3, 1, 2, 3. So that's root 3 over 2 over 1. So let's, instead of 60, let's try 30. So tan is sine over cosine. If we do 30 degrees, 1, 2, 3, 1, that's going to be 1 over the square root of 3. So then y is going to be 30 degrees. We're 30 degrees away from the x-axis, but if we have a negative slope, that means that we're either in quadrant 2 or quadrant 4. Now, we need to back up. Because if we're going to do cotan, we need to be clear about the restriction, right? So cotan is, let's go here. So if we're going to do cotan, so if we're looking at cotan of some angle, right? When you think of the graph of cotan, let's look at the graph of cotan, right? So now tangent is 0 at the origin, so cotan shifts to the right. So cotan is, this is cosine over sine, right? So the zeros of cosine are going to be the zeros of cotan, and the zeros of sine are going to be our asymptotes, okay? So now, tan and cotan both repeat after pi. So say this is pi out here, right? That means this is pi over 2. This is going to be pi over 4 and 3 pi over 4, right? And then say this was like 1 and negative 1, right? Now, so the zeros of cosine are going to be the zeros of tan. So that means of cotan. So the zeros of cotan, it should occur, the zeros of cosine after 90. So this should be a 0 here. And then the zeros of sine, sine is 0 at the origin and at pi. Okay? So then also, so now tangent typically is increasing, so cotan is decreasing, so it's going to pass through this point, and it's going to pass through this point. So the graph of cotan is going to be something like this, all right? This should be cotan of theta, all right? So now this is our graph. So now let's talk about, like in class, so let's look at cotan of theta. Let's identify the domain. So if now we restrict cotan from 0 to 180, then now we have something that's going to pass the horizontal line test, and that means we can talk about inverses. Now the domain of our restriction, it goes from 0 to 180 or pi, but then we use parentheses because of the asymptotes. Okay? We use parentheses because of the asymptotes. Hey, come here. Relax. Have a seat. Come on. Relax. It's okay. Come here. Come here, because I see you gearing up. Have a seat. Come here. Come on. Come on. All right. So, and then looking at this graph, we see that the range is all real. So negative infinity to infinity, right? This is now our domain, and this is the range, right? This is for inverse inverse cotan of y. Yeah, we got Guess here, so she's losing her mind. She doesn't know what to do. I can't do anything with that. She's gonna be like, "Hey, come here. It's okay. I know. Come here. Come here. All right. Yeah, we got company with the whole event going on. But anyway, so now we've identified our inverse cotan. We identified the domain and range for our inverse cotan, right? So let's see what else we got. So now if we go back, now we said that we either need to be in quadrant 2 or 4. So let's look at the original. Now if we say that negative square root of 3 is that in our domain, we should take the, let me see, so the domain we said, so the domain is all real, so we should be okay. So when we get our answer needs to be between 0 and 180. So if we try quadrant 4, that's not between 0 and 180, so that means we go to quadrant 2. That's why we needed the whole orange and purple. So we're still going to stand by y equals 30 degrees. Then we're going to convert it to radians. So now we're ready to go. Let's see. So then we're going to say times pi over 180, all right? That's going to be pi over 6, all right? Actually, back up. So if we need to be in quadrant 2 to have a negative slope, 30 degrees away from the x-axis in quadrant 2 is 150 degrees. So let me back up. Got all these distractions going on. So we need to be 30 degrees away from the x-axis in quadrant 2, all right? So before we convert, this needs to be, let's see. So we're going to say 180 minus 30, that gives us 150 degrees. So that's the 30-degree angle in quadrant 2 that we should be at. So then let's convert this to radians. So then they're both divisible by 3. So it looks like we have 5 pi over 6, right? So that should be the quadrant 2 angle that's 30 degrees away from the x-axis, again, in quadrant 2. If we think about the unit circle, 1, 2, 3, sine over cosine, it should be 1 over root 3, okay? And we have our negative, so we're good. Okay, so this should be the result. Let's look at it one more time. Let's see. So what angle? Okay. Simplify your answer, type an exact answer using pi, using integers or fractions. Okay. So then, now if we wanted to check something like this, now we can't put inverse, oh, actually, we can use Mathway. Now I was going to use my graphing calculator. Now if I was using my graphing calculator, we can't put the original directly in, right? So we would have to manipulate it. So we started at the black line, and then take the cotan, so then we have cotan of y is that, but then cotan is 1 over tan, so then tan of y should be this. So then y is really inverse tan of a negative 1 over root 3. So if I were doing this, checking this in my calculator, I would do the following. So I'll come back to that. So if I was doing this in my calculator, this is about the best that we can do for checking. If you can, this will load. Okay. So we could, in the calculator, all we could do, first, the mode, we're in radians. Then the best we can do is say inverse tan of 1 over, I'm going to say negative square root of 3, right? Inverse tan of all of that. Now we should get some decimal. That should be in radians. Oh, and ours was supposed to be but I think we have to translate it, so we have to say pi plus that answer, so we're in the right quadrant. So we need to subtract that from pi. It should be this. Let's do, now when we do 5 pi over 6, all right, we should get the same thing. Okay, so what that gave us was the negative 30 degrees, but we had to translate it to put it into the quadrant too. Okay, that's why we got that negative. But again, that negative 30 degrees was outside of our range, so that was the wrong section to put it in. So we had to translate it. So another way I'm going to check this in some at home and being leisure, and just to kind of get the swing of things, I'm going to open up a new page and go to this site called Mathway. So now we're doing trig. Now in Mathway, I want to just put the original in. I'm going to do cotan. So I want to say cotan, then to the power, the exponent is here. Cotan to the, I want to say inverse cotan, so to the -1. And then I want to get out of that power. And then I want to say parenthesis, yeah, there, oh, it was there. Negative square root of 3. And then I want to close the parentheses. Okay. That's the original. We should get 5 pi over 6. Let's see what happens. I don't really know what's going to happen. I want to evaluate. Let's see if we get 5 pi over 6. See? There it is. 5 pi over 6. Okay, so again, it's easy to, like, if you kind of put in the inverse tan of a negative 1 over root 3, again, it's going to spit it out telling you that you're 30 degrees away from the x-axis, but you have to kind of infer to know that you need to be in quadrant 2. And again, that comes from this whole graph that you see here. And let me go to Pearson, one other place, and put in the answer. Ask my instructor, can I put in the answer? So we said 5 pi over 6. Say enter. All right. Okay. So that definitely takes a little practice. Again, this, as far as I'm concerned, for this subject, this is like the hardest for the semester. Once we get past this section, I think it starts to lighten up a bit. But again, the main part that was a little dicey, you know, first you have to be clear about your domain and range. So you have your inverse trig function. So you have to be clear about your domain and range. So then, you know, you think about the graph of cotan and then the restrictions that we put on cotan. And then so the inverse, you just flip those restrictions. Then, so once you have the correct graph and the correct restrictions, now when we look at the original, we ask ourselves, is negative square root of 3 in our domain for inverse? Yeah, because we said the domain is all real, so you can have any input. But then that means our output needs to be between 0 and 180 based on our restrictions. So then, so then we did the part on the left with the cotan, and then we have cotan of y equals negative root 3. That means 1 over tan. So that means tan of what angle gives you 1 over negative root 3. So that means we're really 30 degrees away from the x-axis, but we need to be in quadrant 2 because of our restrictions on the domain and range. So 30 degrees away from the x-axis in quadrant 2 is 150 degrees, and then you convert it to radians, and you're good to go. Okay? Hopefully, and that's going to take a little bit for you to digest that. All right? So you just kind of got to work it a few times. So with that, we'll end the session here, and from one beautiful mind to another, enjoy the rest of your day.